All right, welcome everybody. I want you to all kind of relax and try to enjoy this talk that I put together based off of a lot of conversations I've had over the past few years regarding continuous delivery and some of the challenges folks are having with creating pipelines that can efficiently and effectively manage the interoperability between microservices. So let's get started. This is a quick agenda, what I'm going to talk about. But the key thing I want to focus in on is around the orchestration and validation of change. So before we get started, my name is Rivera. I'm a developer advocate at Circle CI. So again, all I do is go to these awesome events and meet these awesome people like yourself and have conversations around what technologies you're using, what kind of trends and operations you're performing. A little bit about myself. I describe myself as a developer with operational tendencies. So I've been in this business since 1994. Started with the United States Air Force Space Command when we actually launched humans in space shuttles. I don't know. This room looks like we have a few folks that could remember that or those days. And I've done a wide range of different disciplines within the tech industry. My favorite though has always been systems integrations. Right, like I've done that pretty much my whole career, and I'm still very, very fond of it. So kind of lean, like I said, more on the operational side. So let's start off with architectures. I'll blow through this real quickly because it looks like everyone in the room probably has a lot of experience and understands what these things are, but maybe we'll do a little refresher for some who don't. So what are architectures? Here's a definition, right, in Webster's. But basically, it's number 5 is the one we're looking at, right? The manner in which components of a computer or computer systems are organized and integrated. Again, that's the number 5 definition. But there are multiple types of architectures, right, that we work with. There's chip architectures, right? We have x86, we have ARM, we have Cyrix, if you remember those. But there's a lot of different architectures. The ones I'm going to focus in on today, or the one I'm going to focus in on is application architecture, of course. But, of course, without a system architecture, right, you don't have the ability to have or even dedicate a application architecture. So I cribbed this off the internet, but when we're talking about systems, this involves a lot of different services, systems, hardware talking to one another, right? Whether it be a network architecture, data layer, database architectures, right? All of these things kind of combined build system architectures. And again, today's focus is on application. So application architecture, right, it essentially defines processes and patterns to design, build, and I would add maintain an application, right? But it also has to meet your business requirements. So who in the room here is a developer? All right. And then I guess I'm assuming the rest are operators, yeah? Awesome, my peeps. All right, so developers are too, by the way. No offense. But at the end of the day, right, this is a simple architecture for an application. And it's a monolithic application architecture that I'm showing you. Right now, we talk about microservices, but I like to talk about them in a more generic sense because it's what we're talking about is composability, right? And being able to take our services and break them out into smaller, more manageable services that can provide a better scalability effort, right? So monolithic architectures, real quick, right? They're designed as an independent consolidated application. We all know this, starting from the mainframe, right? Kind of one of the OG architectures. And then we go and move into probably around, I would say around 1998, 7, 6, around there, 1996 and 1998, we started pairing up our websites with databases and storing persistence in databases, right? But that requires, right, a lot of different services. Today, if you're looking at a monolithic architecture, you're definitely going to see probably a RESTful API and all the other bits around services that I have here that are kind of generic, right? But the problem with these are some of the problems with monolithic architectures, right? It's based on a fixed application and service model. The code base maintaining it without wholesale rewrites is a real pain in the ass. Like, it's super difficult these days to kind of collaboratively make changes to a monolithic application. Who in the room has these issues today? Yeah. You got to wait on some other bit, right? Like a database schema change. Sometimes it's 6 months. I've seen things like be held up for a year because of a database schema change, right? So those are the kind of things I'm talking about here. And then it's harder to leverage using modern development practices. So I'm just showing you, right, the two popular software development practices or principles, I'm sorry, that we engage. Agile is obviously a little bit more modern. And when I'm saying, it's harder to implement the monolithic kind of follows that waterfall methodology, right, in a sense. Or at least in my mind, I equate that to monoliths to kind of that waterfall practice. So if you have that kind of application architecture, it's kind of hard to bust it out into more of an agile, right, management with your software and your SDLCs. And also with continuous delivery, there are some challenges there, but I think the impactful challenge is the release management and monoliths, right? So the commonalities of all those the practices that I just talked about when you're talking about agile and breaking things out of a monolith is you're limiting scope and increasing efficiencies. Those are the results that you should get once you go through maybe decomposing a monolith. So let's talk about composable architectures, right? They're designed to be very specific in functionality and less complex and extremely modular. So again, right, that gives you the ability to reuse these services dynamically, right, and at scale. And again, they come in many flavors. Today, I'm going to focus on microservices, right, because they're the most dominant pattern in tech today. So let's talk about the monolithic again. This time I added a N tier, right? So we're talking about the database layer. But if we were to take this application and break it apart, it would look something like this, right? So now that we've decomposed this monolith, we now have the services that were once all kind of consolidated in one code base. Now we have 4 code bases probably, right? And they all probably will require, their own persistent data layer. So if we look at this in that microservices architecture, this is kind of how it would look like in operation, right? Users go ahead and make requests to your dashboard UI. Your dashboard UI will probably validate some sort of login and then maybe kick in and reach out to the API for their business logic, right? To perform whatever operations, maybe payment, whatever, right? This is just a very simple example. So one of the challenges, though, with decomposing your monolith is code-based management. So again, right, we broke the application out or decomposed it into essentially 4 different services. Now they all have their own RESTful API. They probably have their own data layer, and they probably will have their own repository, right, source code repository. Or you probably can do something like a monorepo, right? It's where you have one repository but multiple projects within that. I am not a big fan of monorepos because I've seen it just adds layers and layers of complexity within the application. I am a big fan of just taking this model, which is one repo for every service. But that also has its challenges for managing that, right? But my preference is the other way. So the reason why I bring this up is when it comes to continuous delivery and composable architectures, there's even more challenges, right? So now that we've broken up our monolith, continuous delivery, right? We want to ensure that our applications are being tested, they're being built, they're maybe even tested for security scans, compliance, whatever you want to do. You're going to automate that stuff, right? And that's where we come into play with CI/CD. Within continuous delivery, there's a concept of CI/CD, which this is just an example of a pipeline, but these are the things, right, that we're automating to ensure that our runs, our continuous delivery runs are consistent and reliable. And the only way you can do that is through automation. Now, in current systems, including Circle CI, The general trigger, right, for a pipeline is a git push upstream. So some developer makes some code changes, they push that change upstream, and then your CI/CD pipeline detects that code change through the push, and then it executes, right, your pipeline. So this is kind of what it looks like when it's in a monolithic code base. Really simple, just one code base makes a change and then kicks off the pipeline. Little diagram or symbol is a pipeline. So in a microservice world, again, if you go with the model that I prefer, you have, right, all these code changes and, or disparate services and repos, so they would all require a push upstream. Now, that pipeline execution occurs, and the execution will, like, let's say we change the dashboard UI, you see this kind of, maybe when you want to run a test in your continuous delivery, you still have to access the user's project, right? The user services project. So what do? Do you have an artifact laying around, right, that you just call? Do you just trigger a build in the user's repository, right, or pipeline? So, there's a lot of different ways to kind of skin this cat. I'm not saying one is better than the other. I prefer having just artifacts existing somewhere and versioned, and then implementing those within the pipeline. But one of the biggest problems that when I talk to folks about, who have decomposed their monoliths is when they're orchestrating their CI/CD pipelines, they're having tremendous difficulties in how to figure out which version of a dependent or service that this other service that this particular service interacts with, what version should they be testing or using, right? Who in the room has this problem with microservices? Yeah, it's really hard, right, to solve. Do you mind me asking, how do you solve this? Okay, all right. One of the ways I hear, like the more common ways, is that whenever a specific service is built and run through a CI pipeline, it delivers an artifact. And then it takes a little bit more work, but folks say they'll do one that's the current and then the past 2 or 3, right? Run maybe 4 pipelines or workflows with those pipelines. So that's one way to skin that cat. But the problem still exists, right? How can we produce microservices that are compatible, or microservice compatible pipelines? At the end of the day, it's about change, right? So we have to start looking at continuous delivery as more of a validation and orchestration of the changes, and we have to focus in on the individuality of those changes. So that's where I jump into orchestrating and validating change. Again, in order to do this, you have to understand the actual application structure. And I don't mean, infrastructure, architectures or anything like that. Literally how the application is structured, how it lives in folders inside of your repository. I'm a big proponent of this for pretty much all my career. I don't want unnecessary cruft in my repositories. I used to manage tons of developers and teams, and I had a standing rule that, like for instance, websites, images could not live in the version control system, even under like an older system like was it Visual Source Safe and SVN, all those things. But the reason why I had that is because there were other folks that were contributing changes, right, to the code base, or to the project, I should say. And developers aren't the only ones contributing changes to your applications. For instance, we have graphic designers, right? We have DBAs who come up with the database schemas. We have network engineers that maybe come up with the infrastructure for the network. We also have security officers that also, right, provide some sort of collaboration around the software. So let's talk about the application structure. I'm going to pick on the images folder, right? If you look at projects, professional projects that I was in charge of, this didn't exist in our repositories. And the reason was, why do they need to live there? The reason that I don't allow it, or I would warn you against it is you don't want to pollute your indexes within Git, right? So this is not an unlimited one-stop shop. We all, as developers and project managers, kind of consider the Git repository as more of a, hey, I can back things up in there, and it's not a backup tool, right? It's a versioning tool. If you need backup, that's a whole different discussion, but developers and even operators these days tend to use Git repos as backups, which is totally wrong. When I talk about images and things that are not source code related, I like to call them digital assets, right? So they're like critical to your application, right? But they are not source code. So if we go back to the application composition, this is probably, this diagram here is probably more realistic, right? Even though we have images, let's say in our repo, if you go back to the other model that I showed you, we serve the images from some sort of CDN, right? Who in the room has images in their repos and then serves the images from a CDN for their solution? Nobody's doing that? Wow, so you guys are all using my model? Just kidding. But at the end of the day, this is more realistic, right? Like this is how production level applications are serving images for like a website. And the reason also is you don't want folks in your repositories who don't understand the tooling. Like I've had so many people, that are maybe graphic designers or DBAs even, try to, cherry pick or revert a change or a commit in Git and then kind of wipe out the history of that whole repository. Who's had that happen to them before? Yeah, one. Usually there's two or three. But yeah, these are the kind of challenges that we all face because we're not really managing our code bases in a way that is equitable for everyone. But one of the things I tell my folks is that digital assets can exist outside of source code. And when you're operating this way, it will help meet your non-developers or the people contributing, collaborating with your project where they are and not in the repositories where they should not be. So my goal here was to provide you all with new perspectives and mechanisms for validating the changes that are occurring in your application. Because after all, that's what we're producing, right? Is changes to the application so that we can get that out to the users so that they can conduct their business on our platforms. And one of my other pieces of advice is your pipeline should not be concerned about source code or digital asset locations, right? So again, kind of paring down a little bit more or going deeper dive into like decomposing the monoliths. I don't think we're going deep enough, and that's what I'm trying to say here is when one of the things that I've had success with microservices is also going into my application structures and peeling out, taking out the things that don't really belong in the source code so that my continuous delivery pipelines can run a little bit more efficiently and effectively. One of the reasons why I say this is, again, in the future, the automation space is obviously going to get even hotter, and it's going to be more important that we decompose a little further down into the application because we want to make things as simple as possible. And yeah, I know I get arguments all the time about, well, now you're decomposing just like we did with that monolith, right? We created 4 different spaces instead of that one we had. But the point there is if you can automate that management, it's a matter of just maybe one file, right? Like that's the way I'm doing it today with all the projects that I manage. And it's probably I'm hedging my bets that it's going to be the future, right? So yeah, decoupling your digital assets from source code helps in building your microservice compatible pipelines. And again, it's really important that you kind of this is the takeaway, is understanding how you're validating your changes. So that's the end of my talk. Wow, that was pretty quick. I do have a little plug for Circle CI. We give we produce a report every year. We just produced it maybe 2 months ago. We call it the State of Software Delivery. So this report includes a lot of information around how people's pipelines are executing on our platform, right? So we do millions of builds per day for our customers. And what we do is aggregate a lot of the information, slice and dice it, and then we produce this report that helps engineering managers and probably above understand how they can benchmark their performance of their teams, right, via their automated solutions or their continuous delivery pipelines. So yeah, if you need to start benchmarking or figuring out how to benchmark, this is a great resource for you to kind of understand the different terms like mean time to recovery, which is when you have a failure, when does that failure get resolved, right? Detected and then resolved. You want to shorten that so that you keep the velocity going. But again, if you have any questions on this, I'd be glad to take them. And yeah, check out the State of Software Delivery report. Well, thank you all for coming. I like the question and answer. I don't want to take questions. I'd rather have conversations. So if anybody wants to throw something out there, maybe I said something that's like a little off and you need some clarification, I'm open. I think we have time, right? Anybody?
Share some thoughts on CI/CD practices in telco.
Haha, telco, man, the hard one. Yeah, so believe it or not, I used to work a lot with, was it Erlang back in the day? So yeah, with telco, we do have, I know of some folks who are using us. It's a challenge. So with telco, emulation is important, right? Like you have to be able to emulate maybe software for a PBX box, which I think actually has, do you work in telco? So you can tell me, has that standard been a little bit modernized?
The positive side is telco have adopted these technologies, right?
Yeah.
Kubernetes.
Cool.
Vendors are also providing CNNs. They're not 100% microservices.
Right.
And people are on a journey. So that's why I think it's good to get inspiration from, let's say, these type of practices and adopting them.
Yeah.
That's my thought.
Yeah, if we're talking about, so the reason why I was asking was, when I hear telco, it's right to hardware for me. For whatever reason, I used to manage PBX boxes, right? And I automated a lot of software to kind of, yeah, AT commands are like right up in here. And I try to forget them, but at the end of the day, so from your perspective, there's different layers to this because the telco companies use everything, right? Networking, telephony. But if you're talking about architectures like Kubernetes, yeah, it's I don't think it's any different, right? Like it's software, and you can apply these principles. Of course, there's always little patterns that are not, say, standard or maybe custom, but you can even get around that by just keeping that concept. And honestly, this is all about people. Right, having to kind of work collaboratively. So culture is really big if you're trying to enforce some of this, or not enforce, but implement and then adopt, have them adopt. Yeah, question?
So to add to that telco piece,
yeah,
even if it can be automated, you're running CNIs or NFVs, it's still, there's DevOps manager involved to do continuous delivery. You can do continuous integration, but when it happened to pass the change, somebody,
yeah.
Technically, it could be fully automated, but sometimes it's that important for somebody to take a look and do the peer reviews and then automate, because even a little change could be very important.
Yeah, and that's more of a, I'm starting to do more research on release management versus a deployment, right? So for me, effectively, release management is the end-to-end concept of your application changes, right? So in the start, it's an idea, and then it has to go through your stakeholders, right? Business level, analysts, everybody has to kind of, product management is involved, security, make sure that, these ideas and changes are okay for the business, and you're gonna make money, to be fair. And at the end of that is a release. Now, the deployment is part of that release, but it's not over yet, right? As we all know, once we deploy the software, someone has to maintain that, make sure it's working, observing it. And unfortunately, the business always focuses on operators doing that job, where, in my opinion, and where I've seen it succeed, is product managers should be able to say, hey, that deployment was bad. I'm going to roll forward or back, whatever you want to use the terminology. And because they know the business, the operators just know, hey, I'm going to get it from point A to B, make sure that everything looks good. Now, product management, you have to drive this vehicle, right?
Everybody focuses on day 0, day 1, but day 2 kind of gets forgotten.
Yeah.
So how to operate that.
Yeah. Any other questions, conversations, topics? Well, thank you, everybody. I appreciate it. I hope this was useful. If you want to have some other discussions, you can hit me up on any of these, GitHub or Twitter. Twitter, not so much these days, but you can find me on LinkedIn, same handle, if you want to connect. Thank you so much. Appreciate you all. Thanks.